Line AB is slightly bent towards the left. It is an air hydrocarbon mixture where you have point E as a lower flammable limit and point D as upper flammable limit.
So what does the slope of AB indicate?
I'll be coming to that. What happens is, at A, you have pure oxygen, pure air, only air, no hydrocarbon in the tank. Suppose the room you are sitting in, it's a sealed compartment. You have 100% air in that atmosphere. Now, in that room, suppose I start putting hydrocarbons. It is totally sealed. I am not escaping anything, but in the same volume, I will start putting the hydrocarbon. So as I put the hydrocarbons, before it was 100% air, now the volume of the air will continue reducing.
Yes, sir.
So as I increase the percentage of hydrocarbon, my percentage of air also, because the volume remains the same. Now same space has to be occupied by air as well as hydrocarbon. So the concentration of air will keep reducing, though it was 100% before. Now as I introduce hydrocarbon, the concentration of air, so that is what exactly it is showing. It is bent towards the left. Reason being, as I increase the percentage of hydrocarbon, the air corresponding to oxygen percentage will continue reduces because volume remains the same.
Okay.
All right.
Thank you, sir.
Right.
Right, doubt, sir. Okay, sir.
Right. Volume is still the same. I'm adding something more. So when I add something into that, suppose in that room that you're sitting in, now you're alone there. Now I put 100 people there. So your presence or the air quantity which is there left will definitely occupied by other equipment also. Understanding? So the percentage of air will reduce in that room.
Yes, sir.
Okay. Can I proceed now?
Yes, sir.
All right. So what happens in tankers? Fire plays a very important role. It's a big hazard on board. Reason being, the three sides of a triangle, that is fuel, oxygen, and heat. All three sides are available on tankers in a very large quantity. So the fire hazards are always there. Fire can take place all at any time. It's so dangerous. It used to be so dangerous to sail on a tanker. Reason being, these three sides are always available in a very large. Since you are carrying fuel, one side of a triangle, they are always emitting. Their vapors are always there. You cannot do anything about it. So one side of a triangle, we cannot do anything. Sparks. Second side is oxygen. Air also is surplus amount available all over. Again, we cannot do anything. And the third side was heat, spark, in the form of sparks coming from the funnel, maybe static current, maybe spray current, maybe stray current, maybe chipping on deck, maybe doing some hot work, maybe some object falling on the steel, generating sparks. So all three sides were available in a very large amount. That's why earlier they used to call, if you're sailing on a tanker, it's a live bomb which can explode at any time. And same is the case now also. But we have taken some measures, lot of measures we have taken to remove this fire hazard. We cannot remove it, to minimize this fire hazard. And what we can do on the three sides of a triangle, we cannot do anything on the fuel side because that is the ship is designed to carry fuel, which is generating vapors. We cannot do anything on that. Then they thought, what we can do, what if we reduce the oxygen percentage in the tank? It's a sealed compartment which has cargo, and above the cargo from the deck head, the vapors are there, hydrocarbon vapors are there. In that vapor, if we don't let any air go in and introduce inert gas and make the atmosphere safe so that fire will not take place. So I can remove one side of a fire triangle. That's how they introduce inert gas. And they put inert gas in the tank, and if the oxygen percentage is less than 11%, which is the minimum required oxygen percentage to sustain fire on board, if I bring that oxygen percentage less than 11%, then the atmosphere becomes safe. So it became necessary to understand. So this is the one way of breaking this triangle to make the vessel safe. We cannot have atmosphere, a flammable mixture atmosphere in the tank at any time. Though we introduce, so this line, AB line, is basically showing the hydrocarbon and air mixture in the tank. C is 1%, but this is for the crude oil. This flammability diagram is for the crude oil, where the upper limit is 10% by hydrocarbon, 10% of by volume of hydrocarbon, and lower flammable limit is 1% by volume of hydrocarbon. This is for crude oil, and this limit, upper and lower limit, changes for different cargoes. It varies for different cargoes. So for understanding point of view, we explain you only the crude oil, and this upper and lower flammable limit can change depend on type of mixture of gases which are present in the cargo. At point A, there is no hydrocarbon and the tank is full of air. As I introduce hydrocarbon, the concentration of oxygen reduces since the volume is the same, and that's why this line AB is bent. On the left side of this, and D is your upper flammable limit and C is your lower flammable limit. This is the flammable mixture. The fire takes place. Fire is not taking place because of the fuel. It's a vapor above the vapors that it is emitting above the fuel level. So the atmosphere above the fuel level is flammable. That atmosphere should not have a flammable mixture. Should not at any stage when the atmosphere in the tank falls into this flammable mixture range, that means there is a sufficient hydrocarbon present, sufficient oxygen present. We just need a spark and catch a fire. You must have heard people are doing tank cleaning and a ship has exploded, and they have done the tank cleaning in a gas-free state. You prepare the tank, you do the crude oil washing, you do the tank cleaning, you open and you find a lot of sludge inside. That means crude oil washing and tank cleaning was not done. You gas free the tank and then you open and see that there is a lot of sludge there. Some smart chief officer, what they do is they just close the hatches, close the tank again, and do the second tank cleaning. Carry out the tank cleaning again without inerting the tank. You understanding what I'm saying? You have already gas freed the tank. That means oxygen percentage is already 21%. You open the tank to check the condition of the tank and you find a lot of sludge. That means the tank cleaning was not done properly. So you decide to do the tank cleaning again. What is the right procedure? Anyone from the tanker side?
Ma'am, sir, first we have to bring the tanks again into the inerted condition and then we have to start the tank cleaning.
That's right. You have to inert the tank first. But you have all kind of people out at sea. These people, they think they know everything. Instead of just they seal it, they close everything without inerting it back to the original atmosphere, safe atmosphere. They do the tank cleaning. So when you do the tank cleaning, what happens? Hydrocarbon percentage, since you're disturbing the sludge in the tank and there is already sufficient oxygen available in the tank, and when you're disturbing the sludge, the hydrocarbons are increasing in the tank. And when it is increasing, you are falling into a flammable mixture. Now the tank is sealed. Why the explosion will take place? Anyone?
Maybe because of heat.
No. When you're doing the tank cleaning, you're disturbing the sludge. You are generating the static current that will act as a spark. Now all three sides of the triangles are available in the tank. A beautiful atmosphere to have an explosion. You have a fire, and then after that you have explosion. So understanding this diagram is very important to have a safe atmosphere on board. All level is required to know this diagram so that if somebody is making some mistake, some other person can stop and avoid a disaster. So if I am at this stage, if the tank atmosphere is full of air and I have a hydrocarbon here, in the crude oil, this is 10% by volume at D, that is upper flammable limit, and lower flammable limit as 1% by volume. It has been observed when I introduce inert gas in the tank. If I put inert gas here, there is a drastic change of atmosphere taking place in the tank. Inert gas with the 8%, less than 8% or less than 5% of oxygen. When I introduce that, this upper flame, there's a drastic change of upper flammable limit as it is going down. Drastic change in the upper flammable limit, though whereas lower flammable limit more or less remains the same as the inert gas is introduced. On the left side of this line AB is an inerted atmosphere. You are introducing inert gas into the atmosphere of the tank. So as the inert gas is introduced, there is a drastic fall of upper flammable limit, and both, though the lower flammable limit remains the same, and they meet at a point known as E, which is at 11% by volume of the oxygen. That is the minimum percentage required to sustain fire. So my atmosphere in the tank should never fall into this range. This is upper flammable limit. It's a limit, it's the uppermost limit above which the fire will not take place. Lower flammable limit is the lowest limit of the hydrocarbon air mixture below which the fire will not take place. Am I right? So
Yes,
far
sir.
so good. So this atmosphere has to be kept. This diagram is there on board anywhere displayed?
Yes, sir.
Yes.
Yeah, it is displayed in the cargo control room, and it's a good idea that senior officer must explain this diagram to during your training time after the drills. It's a good idea to explain once in a while, explain it to the whole crew, the significance of this diagram as far as tankers are concerned. Whether it's a tanker or a chemical carrier, any kind of tanker, this flammable diagram plays a very important role to understand why the atmosphere in the tank should be safe at all times. So as I introduce the oxygen, the inert gas, the atmosphere above the upper flammable range is known as too rich. That means too much of fuel available in comparison to the oxygen. Fire will not take place. Oxygen concentration is not enough to sustain the fire as the fuel is too rich. The vapors hydrocarbon percentage is too rich. So this is known as too rich atmosphere to have a fire. Below the lower flammable limit, the hydrocarbon percentage is too less to sustain fire. So below the lower flammable limit, the fire will not take place as the hydrocarbon percentage is too lean to sustain fire. So fire will take place as long as the atmosphere inside the tank falls under this triangle, this flammable mixture.
Excuse me, sir.
Hmm.
So this E point, it defines too rich and too lean. Like above E point it is too rich, and above below the E point is too lean. It is the factor which decides too rich and too lean.
No, E is just a 11% oxygen. E, the line DE is your upper flammable limit, and EC is your lower flammable limit. E is a point where this upper flammable and lower flammable limit they meet.
Sir, I
And
had one question. Sir, regarding the tank cleaning, which you told that if the tank is already been gas freed and when we open we find some sludge, so we will dilute it, we will re-inert it, and then after we'll start it tank cleaning. Sir, my question
correct.
is, ma'am, sir, my question is that if the tank is gas freed, means for that time being the hydrocarbon percentage is already zero. So we can start again gas freeing, sir, and at the same time we'll start tanking. So in the meantime we will be diluting, so the atmosphere will never reach to lower flammable limit only if we continue gas freeing and then tank cleaning.
No, then it becomes an open gas. You're doing the tank cleaning in the open atmosphere. It should be a closed system. One. Second, you are disturbing the sludge, and hydrocarbons are heavier than the air. It will stay at the bottom. You understanding? And it is getting mixed up when you disturb the hydrocarbon. This sludge, it's emitting the hydrocarbons and vapors. And if you have a right mixture inside the tank, and a static current is already flowing, you will have a fire first you will have a fire, and then you have a explosion. That is why it is required. These are all the shortcuts, these are not mentioned in any of the procedures. Understanding what I'm saying?
Okay, sir.
Nothing. Some people are doing like that. You're right. You must have come across people doing like this. Nothing happens. That doesn't mean it becomes a procedure. Had that been safe, they would have put it in your safety management system. Have you seen it written in the safety management system? SMS? Hello? Is this procedure written anywhere?
No, sir, not written anywhere. But I was just saying that if
No.
the atmosphere will be too lean, then we can continue like that. That's why I asked you.
But to maintain its too lean, you have to continuously monitor it. You're taking a risk, and there is not much of a difference The atmosphere might enter the flammable, maybe the small pockets or few pockets in the tank have a high percentage, they fall into this. You understanding what I'm saying? Even if
Yes,
you're
sir.
continuously venting the tank, but still there are some pockets left untouched where the hydrocarbon percentage are very high. So it's just taking a risk, and it's absolutely not necessary to take a risk. They have laid down the procedure, are absolutely safe procedure, because there's not much of a gap here from 0%, and it's just 1% by volume. From A to C is 1% by volume of the hydrocarbon. 1% of hydrocarbon.
Yes, sir, I correlated because sir, in this tanker manual also for open tankers where there are no IG, it told like first you gas free it, then after you start tank cleaning, and then if the hydrocarbon percentage reaches like 30% of the 33% LEL, then you stop again gas free, then again. So
The
sir, I
tedious,
correlated that.
the see where you don't have inert gas system, usually they are carrying non-volatile cargo. Where you don't have inert gas, no, they are non-volatile cargo. The flash point is very high. You can take risk over there. But most of the tankers, they are carrying, and inert gas is mandatory on the ships. When you're carrying a volatile cargo, it's mandatory. And people are trying this same trick that you're mentioning, and on the ships which are carrying volatile cargos. Volatile cargo means the flash point is more than 60 degrees Celsius. There you can take a risk like that. When the LEL comes to 33% of the LEL or 50%, then you stop and then vent it out, and then those procedures can be done on a non-volatile cargoes where there is no inert gas. When there is no inert gas, you have no choice. You have to follow this. But for the volatile cargoes, you cannot take these chances. Okay?
Yes, sir.
So this is upper flammable limit and a lower flammable limit. Now we know why the line AB is bent towards the left. We cannot afford to have our atmosphere inside the tank to fall under this flammable mixture range. When we introduce inert gas and when we reach point E, we continue to introduce inert gas in the tank. Keep this oxygen percentage keep coming down as safe as possible, as far away from point E as possible, so that we can thoroughly remove this one side of the fire triangle. We are absolutely sure that we have the range between the oxygen percentage is usually 5% in the tank, and minimum required is 11%. It's a big 6% of volume of oxygen gap in between. So one side of a triangle is safely removed, and there's a huge safety margin between that. That's why MARPOL came out with the requirement to have an atmosphere inside the tank. The oxygen percentage should be 8% or less than 8% by volume.
So, but Solas is saying it should be less than 5%, correct? For IG?
No, for IG. I'm talking about the tank atmosphere should be less than 8% by volume. The shipping companies, they came out with the extra safety. They said no, 8% is still very close to 11%. We'll keep the atmosphere 5% or less of oxygen in the tank.
So that is as per Solas, correct?
Now, the SOLAS says the the IG system should be capable of delivering inert gas with the oxygen percentage less than 5%. It's a requirement for the inert gas generators. Inert gas system should be such that should be capable of delivering oxygen percentage less than 5%. When you have less than 5%, then only you can maintain less than 8% in the tank. Isn't it? So there's a huge compartment. It will take very long time to reduce the oxygen percentage. So they further started diluting, continue putting the inert gas in the tank, and in the process they have diluted and they have kept the safety margin far away from the point E. So having an inert gas in the atmosphere, provided my oxygen percentage should be well below the 11%, then it is absolutely safe atmosphere. That's why we are checking when we are doing this inerting of this tank, we are checking the oxygen percentage, not the hydrocarbon, oxygen percentage. So that one side of a triangle is kept as far away as possible. It's totally broken. So we reach atmosphere like point F, where the oxygen percentage is almost 3 to 4%. We keep putting the inert gas till we reach point F, which is absolutely safe atmosphere as far as the fire is concerned. So fire hazard has been taken care of. Not only this, MARPOL and SOLAS have taken care of the spark side, the second side of the third side of the triangle. There is a special tools for chipping. You cannot use hammer or big chipping tools. There are needle guns which are generating, still generating sparks, but it is in the controlled manner. They have introduced the flow of liquid inside the tank should not be more than 1 meter per second. By doing so, the static current generation is zero. When the flow of liquid is through the pipe is 1 meter per second and going into the tank, the static current generation is not there. They have come out with this regulation. Third, hot work procedure has become very stringent. Nobody is appreciating doing a hot work on ship, on tankers. They are forcing people on board to come out with some cold work and solve the problem. Unless until it's absolutely necessary that you have to do hot work is not so common in tankers nowadays. Am I right?
Yes, sir.
And nobody is appreciating that to carry out the hot work. So they have taken a lot of no smoking regulations has also become very stringent now. Only in the one corner of the ship, dedicated smoke room you can smoke. So there are a lot of so the third side also of the triangle, they have tried to take care of that so that these three sides should never meet. And by taking so much safety, that's why safety is a big issue on ships, on tankers, especially on tankers, because these three sites are available in surplus, too much, in a very large quantity, and these three sites has to be kept away from each other at all times, whether in port or sailing or in dry dock. This danger is always available. So another factor comes when, suppose I have atmosphere at F, and if I have to gas free or man entry or do some repair or some cold work or whatever, if the atmosphere in the tank is at F, that means there's a high percentage of hydrocarbon and very little percentage of oxygen in the tank. If I start purging with air or dilution with air, the oxygen percentage will start increasing and pass through the flammable mixture and reach A, which is not safe. Agree with me? Because in the process we are passing through the flammable mixture. So what I can do, another alternative is, suppose I reduce the hydrocarbon percentage first and bring this is the y-axis is hydrocarbon percentage. I reduce the hydrocarbon percentage first and then put the inert gas, then put the fresh air. So how can I reduce the hydrocarbon percentage? If I put the inert gas here and start venting, I'm venting out the hydrocarbon and the hydrocarbon percentage is coming down. And when it is sufficiently down in a safe margin, safe zone, I introduce fresh air and it will follow the path. That change in atmosphere or increase in the oxygen percentage will follow the path of H and A. And this HA is not falling into the flammable mixture range. Atmosphere during the whole operation absolutely safe. I'm not passing through a flammable mixture at any time during the dilution, during the purging. That way, I'm keeping the three sides of a triangle far away from each other at all times. Now, how much the dilution, how much hydrocarbon percentage should be done? It depends on lower flammable range. What is the lower flammable range of that particular cargo? For this purpose, it is 1% by volume. So suppose I lower the hydrocarbon percentage to 1% or 2% by volume, and then when I introduce fresh air, it will definitely fall into the safe zone. There is one more column called critical dilution with air. Suppose I reduce the hydrocarbon percentage to 5%, somewhere I fall, and then put the air. So till this critical dilution air, I have to reduce the hydrocarbon because till critical dilution, critical value, the atmosphere in the tank will fall inside the flammable mixture. So this is the minimum quantity of inerting required before we start the dilution with air. Am I making sense? This statement is making sense that this is the minimum critical dilution with air is the minimum quantity of inerting required before we start dilution with air.
Yes, sir.
All right. So this is the minimum quantity, and it has to be more than that. Then my hydrocarbon percentage should be well below this, and then only the dilution with air should start. So now
Sir,
we have. Go ahead.
so this critical dilution line is made with like rough hand, right? For different cargoes, first we'll make this graph and then we'll take the scale and make this like
Correct.
this by.
Correct. See, more or less, you can to be on a safer side. Suppose if it is this some other cargo, if it is 2% upper flammable limit, I draw a line here till the 11%, and draw a line. It need not have to be absolutely curved or something, but draw a line parallel to the x-axis. Draw a line here. That is my, and if it is where it is cutting, it is 2% by volume. So my percentage should be, it will be something like that, a triangle like this, and dilution will be somewhere, you make a tangent to that, and somewhere it will be 5% or something. So that will be approximate critical dilution line. So when I'm doing the inerting, I have to be absolutely sure that my hydrocarbon percentage is well below the critical dilution range, so that when I introduce fresh air, I am at in an absolutely safe atmosphere throughout the operation. Okay.
Yes, sir. Okay, understood.
Right. So
And
this
also,
is,
sir, also this E and C range will always remain the same for oxygen, right?
why because why E will remain same, because this is the oxygen percentage. Minimum oxygen percentage required to have a fire, to sustain a fire on board, is 11% and more. Minimum is 11, and more the better to have a fire on board. So the point E will remain the same. If it is here, if the lower, any question, anyone?
So once again the slope, sir.
AC, AB or AC. AC is the lower flammable range. B is the upper flammable. B is the upper flammable range. C is the lower flammable range. This is D. Above D is too rich to have a fire. Below C is too lean to have a fire. The hydrocarbon percentage is too lean, too less to have a fire. Whereas above D, the hydrocarbon percentage is too much to have a fire, and oxygen concentration is very less compared to the presence of hydrocarbon. So that's why it will not sustain fire. Okay, and in this area, when it is less than oxygen, less than 11%, the oxygen percentage is too less to have a fire. Minimum percentage required to have a fire is 11%. Usually it is 11.5, but for practical point of view, you can take 11%.
Sir, some cargoes, they eat up oxygen and then they produce lots of hydrocarbon gas. So while carrying those kind of cargoes, if we don't inert, I think it's still kind of safe. So
you have to have, you cannot afford to, you cannot allow the fresh air to go in. Even if the pressure has gone to negative, you should never at any stage allow this fresh air to go inside the tank. Yes, you are right. Some cargoes are like that, they eat up all the atmosphere. Or if there is a change of temperature, the temperature decrease in the temperature. Suppose you go from warm climate to a cold climate, the pressure inside the tank goes to negative. First of all, you should never let it go to negative. Second, do not let the fresh air from outside to enter through the PV valve, or the vacuum, the negative pressure has gone so much that it has lifted the PV valve or PV breaker, and the fresh air has gone in. No, you cannot. That way, you are increasing the percentage of oxygen in the tank. Yeah. So you are making the atmosphere in the tank as dangerous as the oxygen. That is a trick of this. That is why it is mandatory to understand the flammable diagram.
yes, sir.
That's why they say you have to maintain a positive pressure inside the tank at all times, whether you are alongside or out at sea. That's why we are getting up in the night and topping up the cargo tanks with the inert gas.
Yes, sir.
Because we cannot afford to have this is the way. These three sites are surplus in amount is available in the on tankers, and we cannot afford to have them meet each other to make a triangle. That is the idea of making If you have an inert gas in the tank, that's what I said. Introducing inert gas also doesn't make a difference. It's not making the atmosphere safe as long as the oxygen percentage is less than 11%. Very important. We cannot afford, we cannot allow this fresh air to go inside the tank. We are generating a dangerous atmosphere in the tank. That's why inert gas is a requirement for inert gas to generate less than 5%. Otherwise, they will not pass the inert gas system. It should be designed to deliver oxygen percentage less than 5%. So that is after introduction of this, taking care of all these two sides of a triangle, the tankers have become a safe ships. It's one of the safest ships now.
Sir, one more doubt, sir. Sir, if we are given, suppose a product we are given, and we are given its upper and lower flammable ranges, and then how can we draw that E point for that? Means that flammable whole range for that?
Suppose the lower flammable was 5%. It will fall somewhere here. Just draw a line parallel to the x-axis, and where it is 11% here, where it is cutting here, that becomes a point E. You understanding that? So when
Sir, means the average of both the upper and lower.
Yeah, that's where it is meeting. It has to meet at 11% because fire will not take place on the left side of the E because there is not sufficient oxygen. For fire to have, you have to have oxygen, and minimum percentage of oxygen is 11. All right. So
Yes, sir.
if it is 5%, the E will be somewhere here. So if I'm inerting, if I'm gas free, I have to inert the tank below 5% and then start putting the air inside, so that I stay during the whole stage of my operation. I stay in the safe atmosphere.
So,
Okay.
if we have a cargo and we know it's LFL and HFL, then can it be depend on the volume of the cargo? It can define the HFL and LFL if it increases or it decreases volume.
See, it depends on the percentage of the gases which are present in the cargo. It will not change. For that particular cargo, it will not change. The limit will remain the same, more or less remain the same. But most of the cargo have a mixture of lot of gases. So if you say that this is the lower flammable values of different cargoes of pentane, butane, benzene, propane is 2.3, gasoline 1.4. These are lower flammable limit for these cargoes, whereas upper flammable limits for different cargoes are like that. It's varying.
Sir, if we increase the volume or decrease the volume, then it will change or not?
It will remain, the value will remain the same. No? See the
So
upper low. Yeah, go ahead.
So then how this LFL and HFL
They are calculated not on board. They are calculated in the lab, and it will be mentioned maybe in the MSDS sheet, or it may be mentioned in the quality certificate. Okay.
Yes, so they mention on MSDS, but it will not depend on the volume. Or,
it will not. See, when the fire is taking place, it's a fire because of the vapors, not because of the fuel. The vapors that it is generating.
Yes.
And it will remain the same. The limits will remain the same. As it is mentioned in the MSDS sheet, it will remain the same.
Okay.
Okay. But the thing to know is that it is not 1% by volume for all the cargo, or it is not 10% by volume for all the cargo. It varies. We must know that. And secondly, we must know through the MSDS sheet what are these values and carry out if we have to, because in the chemical tankers or a product carriers, it is very common to carry out the gas spring. So when we are doing this gas spring, we must understand this flammable diagram. At any stage, we should not fall under this flammable mixture at any stage of the operation.
Okay.
Anybody has any doubt now? Okay, we stop it here. Next class we'll go through the slides also and make sure that we understand. If you still have a doubt, we will clarify in our next class. Thank you very much, everyone.
Sir,
Thank you,
can
sir.
I ask a very stupid question?
Go ahead. It's still here. Go ahead. As long as it depends on the temperature, outside temperature. It depends how if the temperature is high, the vapors, emission of vapor will increase. If it is in the cold atmosphere, the vapors will not emit so fast. It keeps changing. It depends on the outside temperature. Or if it is a heated cargo, as the temperature of the cargo is increasing, the vapors also increasing.
Okay, but sir, let's say the temperature is sufficient. भरा हुआ है ज़्यादा, वहाँ पे
because the volume, the space available for the full tank is less. Space available above the fuel, the air space which is available on top of the fuel, it's very less.
No, sir, let's assume that the space available in both the tanks is the same. Above. Yeah, both are half filled like that, yes. One
Acha.
tank is bigger and one tank is smaller.
Yeah.
So bada wala tank jo hai, that will get filled up faster.
Depends on temperature.
Okay,
Outside temperature, the both cargoes will be emitting the same amount of vapors. I mean, what you're aiming at? What you're trying to say?
Sir, I'm trying to ask कि let's say there are two tanks, एक छोटा है, एक बड़ा tank है.
Okay.
Thank you, sir.
Anyone? No problem. Anyone? Okay, guys, we stop it here. We'll continue in our next lecture. Thank you, everyone. Vijayendra, thank you.
Thank you, sir.
Thank you, sir.
Thank you, everyone.
Bye, sir.
Bye, Vijay.